These pictures show several examples when an object, a car, travels and the velocity changes. Case A. How does it travel? Velocity points to the right, so it travels to the right. And it says speeding up. How would we describe the acceleration? We need to compare two velocities. This picture, the first snapshot, gives velocity number 1. We can call it initial velocity. If we wait a little bit longer, the velocity should be higher because it should travel faster. And the representation for that is a longer arrow, but it still points to the right. Now, we have no intuition on using arrows or symbols. It's easier just to pick up a number, like 3 meters per second. In that case, for the next velocity, I should pick a number which is what? Same, less, larger. Any larger number would work. Let's say 7 meters per second. I like 7 as well. So now if I want to calculate acceleration, I would have to do this. 7 minus 3 divided by delta t. Time always goes ahead. It doesn't go back. So delta t is always positive. 7 minus 3 is 4. So that's going to be some positive number. Positive number. What does it mean? It means acceleration also should be represented by an arrow that points to the right. I'm not going to go through all examples. Let's do C. C. That is velocity at some initial instant. Let's set it to a convenient value. Please tell me at any number which could represent this velocity. Negative 10. Why is it negative? Velocity points to the left. It travels to the left in 10 seconds. Be final. First, if you want to draw an arrow that represents case C after a while, should you draw an arrow of the same length, longer or shorter? Shorter. Why is shorter? Because it is slowing down. And now, what number can we assign to this velocity? Of course, it cannot be negative 10 anymore. It has to change. What would it be, negative 15 or negative 5? Shorter. So the magnitude should be smaller. Something like this. Now, acceleration, which is again v2 minus v1 over t2 minus t1. V final. We can call it v1, v2, interchangeable symbols. So negative 5, because it's there. Now, what symbol do I have to write? No, I have to write a minus, this minus. Now what do I have to write? Negative 10, because this represents this velocity over delta t. Negative 5 minus negative 10, what is it? So, what is it? Of course, this is something you should know intimately. Minus and minus makes it plus. So it is negative 5 plus 10 over delta t, or 5 over delta t. That makes it positive. So what is the direction of an arrow that represents acceleration now? If it's positive, to the right. So an arrow that represents this acceleration points to the right. You can do it again and again, and for each time when an object is speeding up, velocity and acceleration always point in the same direction, and each time when an object is slowing down, velocity and acceleration always opposite to each other. Each time when an object is speeding up, velocity and acceleration point in the same direction, and each time when an object is slowing down, velocity and acceleration point in opposite directions, and vice versa. If we know that velocity and acceleration are opposite, the object slows down. If we know that velocity and acceleration parallel, point in the same direction, the object speeds up. That's a very convenient relationship to remember. All right, so I basically did this.